if you've got two people standing, but one of them is standing on a platform that is higher than the other one, what will you tell him? You'd say, excuse me, please, can you come to the same platform so I can measure your heights? So it's very natural for us to expect that when you are measuring magnitude, the two guys must stand on the same level. They must stand on the same ground, and then we can measure who is taller than who. So therefore, in this same case, I want you to realize that these fractions are just like that. What we refer to as the denominator is actually what they are standing on. 2 is standing on a 3 ground, 4 is standing on a 5 ground. You cannot compare their heights because they are not on the same ground. So what do you need to do? You have to make sure they share the same kind of denominators. We don't want to see different things and still compare. If the question were like this, just look at this one. If I had said 2 over 5 and 3 over 5, which is bigger than which? Obviously, because they are standing on the same ground, I'm happy to say 3 over 5 is bigger than 2 over 5 because 3 is bigger than 2. So, yeah, 3 is greater than 2, 2 is less than 3. So 2 over 5 is less than 3 over 5. But in this case, they are not yet on the same surface. So how do we do that? A very straightforward thing to do, which is natural, is how about if I multiply this 3 by 5 and I multiply 5 by 3? So I have 15 and I have 15. That gives them the same surface. So how about if I do something like this? 2 over 3, 4 over 5. And I say 3 times 5, 5 times 3. That gives this 15 and that gives this 15. Normally, I should be very happy to go ahead now and compare these guys. But I cannot just multiply the denominator without doing anything to the numerator. Otherwise, I'll be changing the question. So, because I have multiplied the denominator here by 5, I have to multiply the numerator again by 5. Because I have multiplied this denominator by 3, I have to multiply this numerator by 3 as well. Now, the question is balanced. We can go on now. 2 times 5, 10. 3 times 5, 15. 4 times 3, 12. 5 times 3, 15. Are they or are they not standing on the same platform now? Yes, they are. Which is bigger, 12 or 10? 12. So, this is less than that. Happy? That is the simple way. Now, a tricky question will be, what if I've got many numbers like 1 over 2, 3 over 4, 2 over 3, 5 over 6, and I'm told to compare in order of increasing order, which is bigger than which? Am I going to do the same thing like multiply 2 by 4 and 3 and 6? That's going to be a little bit tedious, because what if you've got something like 9 over 11 as well? You're going to be having some really very cumbersome approach to that. So what we decide to do is to look for the smallest number that can take care of that problem for us. Okay, and I'll just point this out to you here. We had 3 and 5 and we got 15 at the end. What do you think is common? What do you think this means really? I mean, 3 times 5 are factors of 15, right? So that's all we did. We looked for the nearest big number that can be divided very conveniently by 3 and can be divided by 5. And then we looked for the complementary factor to that and multiplied the whole thing out by it. So that takes us to what we call the LCM. Okay, the LCM. And it's actually the lowest common multiple. And problems like this occur every day when you're trying to know which is bigger than which. Okay, so it's something worth learning, not just because of the exams, but